Okay, this is Unit 7, Day 2, and we're going to start talking about these special lines that are in triangles. And we're going to talk in general about what all these four kinds are. And I want you to kind of look at these pictures, and we're going to work through what is true about each one. And we're going to put a check if it's true for that one. So the first one is an altitude, and this is an altitude here. Does it go through a vertex? Well, a vertex is one of the corners of the triangle. Does it go through a vertex? Yes, it goes through that one, so that's true. Is it perpendicular to a side? Perpendicular means it makes 90 degrees, so yes, it does. Bisect a side. Remember that bisect, we've talked about this word before, it means it cuts in two equal parts. Do I see anything about this being two equal parts here? No, so that's not true. And bisects an angle. Does it cut it into two equal parts? No, so that's not true. So an altitude goes through one vertex, and it's perpendicular to a side. Now the next one we're going to look at is a median. A median, does it go through a vertex? Yes, it does, right there. Is it perpendicular? No. Does it bisect a side? Yes, and I know that it bisects a side because this part is equal to this part. That's two equal parts. This point here is also the midpoint because it's right in the middle there. So it bisects the side. Does it bisect this angle? It might look like it, but it doesn't tell us that it does, so that's not necessarily true. So a median, it goes through the midpoint, it goes through a vertex, and it bisects a side. Our next one is called an angle bisector, which should already be a clue here. It's going to bisect an angle. And look, there it is right there. These two parts are exactly the same. So it bisects an angle. Does it go through a vertex? Yes, it does right here. Is it perpendicular? Nope. Does it bisect a side? Is that the same? Nope. So it just goes through the vertex and it bisects an angle. And our last one, the name almost tells us exactly what it does. It's a perpendicular bisector. So we know it's perpendicular to a side because it's right in the name of it. So perpendicular to a side. And it bisects this side here. Again, this is the midpoint. And it bisects this side here. So bisects the side, that's this one. Does it go through the vertex? No. And does it bisect the angle? Well, it doesn't even go through the angle, so it doesn't bisect it. So a perpendicular bisector is perpendicular to a side, and it bisects a side. So this is real important because the first thing we're going to need to know is what all of these are. And you're going to have some practice just naming, looking at the lines, and figuring out which one it is. Now the rest of today we're going to spend looking in particular at these two kinds in more detail. And we'll look at the other two in more detail next time. So, in altitude, here's the actual definition. In altitude, we know it's perpendicular to a side. It's a perpendicular segment from a vertex to the opposite side of a triangle. And I have several different kind of triangles here because it looks different in different kind of triangles. I've got a scalene, I've got a right, I've got an obtuse, and I've got an isosceles. This one is also an acute triangle here. So in a scalene triangle, it looks just like up there. It just starts at one of the vertexes and goes down, and it's perpendicular. And as a note, I could also draw it, if my triangle was sitting like this, this is still an altitude. It doesn't always have to come from the top. It could come from any of them. And in fact, I could draw in one like this as perpendicular going to that side. In a right triangle, if it's on the side where it's the right angle, it's actually the side of the triangle here. So if I'm going to label it AB, this side right here, this is the altitude of that side. It's actually the side of the triangle. And the altitude on an obtuse triangle, it actually can be outside the triangle like this, where I just kind of do a straight line going out, and that's the altitude right there on an obtuse. And then an isosceles, it comes down straight in the middle like this. Okay, so a median, that's like this one right here. A median is a segment from a vertex. We know it went through the vertex. that bisects the opposite side of the triangle, bisects the side. So we're going to draw it again here. So each time I need to find the middle of the opposite side. I'm going to kind of just look and figure out where the middle would be on this side. And then when I draw these, I know it goes from the vertex to the middle each time. So this one, look, the scalene and acute triangle, that looks pretty much like this. The right triangle, it really works out pretty much the same. It looks very similar to this one. In the obtuse triangle, it still looks a lot the same, like it's pushed way over, but it still goes right to the middle. The isosceles one is the one I want you to look at. What do you think about these two triangles and the lines here? The altitude here and the median here, do they look like they're in the same place? Because they are. These two are the same in isosceles triangles. So if we happen to be talking about an isosceles triangle, the median and the altitude are the same line. In an isosceles, triangle, the median is the same as the altitude. They're the same line. You should be sure to write this down because this will come up various places and you need to know that those are the same thing. Were they in the same place on any of these other ones? No, it's just an isosceles. And on equilaterals, where all the sides are equal, it's still going to be the same thing. So now let's look down here at some practice problems. And what you have to do first is figure out, what does the thing tell me? And on your knowledge check you're going to have next time, it's going to ask you the same thing. This one tells me it's an altitude. What does that tell us? It tells us the important thing about the altitude is that it's perpendicular. Tells us perpendicular and 90 degrees. Remember, this is our little symbol for perpendicular. It tells us that it's 90 degrees. So I can put that on here. I know that's true because it's an altitude. Now I can work out the rest of the problem. The problem tells me also that ADC, this angle right here, is 4x plus 10. Well, what angle does that have to be equal to? Well, it's 90 degrees because it's an altitude. So that's my equation I'm going to write. 4x plus 10 equals 90 because it's an altitude. So then I'm just going to solve this. Minus 10. 4x equals 80. X equals 5. This next one, it tells me it's a median. What does that tell us? It tells us, if it's a median, it tells us that it bisects the side. That means this is equal to this. It tells us the side is bisected, which means that FT equals TG. That's what it tells us just because we know it's a median. So then the rest of our problem says, well, find GF, the whole thing, if TF, this much, is 6.3. Well, if this is 6.3, what's this? Well, that's 6.3. And they asked me to find the whole thing, GF. So 6.3 plus 6.3 is 12.6. Okay?